After I get an idea about the failure by testing, I can now have a look inside the faulty cable with my TDR, because I want to see if it is a break on the way from the beginning to the far end, or what happens. And also I want try to get the real velocity of our cable length to get the best results for the next step for arc reflection mode. Okay. For this we have to select pre-location. In the beginning don't use quick steps arc reflection. First start with TDR. TDR means time domain reflector. It's a low voltage output signal without any high voltage. It is only 60 volts output. This TDR is working like a radar system. You know it from airplanes, and if there's something on the way, an impedance change by a coil or a T-joint or something else, a different kind of cables, you will get a reflection, and this reflection we can see on our screen. The next step is, this is a low voltage mode. That means still the green light is on, no high voltage in use. The first is we have to adjust our picture. If you know the real cable length, you must adjust first the display range. In our case now we have connected at our cable from the test well cable drum only a spark gap. That means our cable is not longer than 50 meters. What we see now on the screen is, this is our beginning impulse. This is impedance change from here through the system and the connection point of our cable drum, high voltage cable drum, and this should be our cable end. So if we get a better picture, we have two options to adjust. First we adjust the pulse width. 35 nanoseconds is for very short cables, and if the cable length is longer, then we have to change it to 100, 200 and so on. So let's do it. And you see immediately we get a different picture to the beginning. That means now we are using a pulse width of 140 nanoseconds. Okay, confirm to close that window. Then the next option is we can go back to the gain. If this is not a good picture for you, you can adjust the gain also to get better results. Okay, confirm. The next step is, these steps are all the same in all kind of TDR, arc reflection mode and so on. The next step is what's this display range? We must set our real velocity. For this we select this button, switch it on. Now we have two options also. First we can take the velocity out of a file, which is here we can see different kind of cable types with an average of the velocity. But if we have two different of cables or three different kind of cables in our cable, we must adjust the average value of everything. So for that we have to go back, adjust our cursor, the end cursor, to the far end. We have to put it at the point where the curve goes up, at this point. This is our 0 point. Okay, we go back. Now we additional menu. We go to the start cursor, set the start cursor in this case at the beginning. The beginning means from here, and it shows me now the distance between these two cursors. So what is important to know is, by your diagrams, the real length of your cable. If you don't know this, you must go outside, check your trace and use your wheel to check the real length of your cable. And now you must adjust the distance between these 2 points to your real length of your cable. That means, for example, 1 second, let's go back. We adjust now the velocity by hand. If our real length is only 60 meters, you see we have to decrease here the velocity so that we reach the real cable length at this point. That means the real cable length of our test span is in this special case 60 meters. If your cable is much longer than 60 meters, about 80 meters, you must do the same steps, but then you have to increase to reach the real value. Okay? After all these adjustments, you get the first overview what happens in your cable. This you can do in all 3 phases, because we can memorize all the pictures. So we have a single phase system now, compact city, and for example this is our picture from phase L1. So the next is we can store, select here and press, and automatically we will store the black curve into the blue one. That means the blue curve is now active, memorized, and the black one you see behind is active, sorry. So if something is different to the phase L1 and L2, you will see the difference now. If you have a 3-phase system, you also can put now this curve into B, and then it's the same function. You have A and B memorized, and still the black one is a live picture, so you can compare all 3 phases in one picture. It is necessary because we want to see if the cable reaches the far end, if there is no cut on the way, no break, and so that's it for this moment.